Now that we've studied exponents, I would like to go on to this program that's right under this Egyptian's hand right here. It says Easy Power. I wrote this program much later than these other two. It was after I was teaching calculus, and I realized that students were so calculator dependent that they did not even take the cube root of 8 mentally. They thought that they had to have a calculator to do that, or even the cube root of 1. I call this Easy Power because there are some problems that can be done mentally much quicker than on the calculator. And a lot of times the evaluations that are done where they ask part to be done on a calculator and part to be done without a calculator, they will rely on the properties of these numbers than in Easy Powers to see if you really can do the concepts in your head without a calculator. So let's look at this Easy Powers. The problems in this program can be worked without a calculator in case you didn't get the message. Let's look at Easy Powers, and let's just work some of these. I messed it up by moving these windows around. 125 to the 2/3 power. Now this fractional exponent, I haven't explained, but I want you to know that with the fractional exponent, the numerator is actually being raised to the power, and the denominator is a root. So the first thing you'd want to do is to make the number smaller. So this, if you ignore the 2 and thought of this as to the 1/3 power, this would be taking the cube root of 125, which means what number times itself? 3 times would give 125. Well, that would be 5. So the cube root of 125 would be 5, and then you square that. So the answer to this problem is 25. I hope you followed that. We win. New problem. This is 64 to the 1/2 power. This is the same as the square root of 64, or the root of 64, the positive root, which would be 8. Check. We win. Oh, this is easy. The 5th root of 1 is 1. 1 cubed is 1. I couldn't believe the number of students that would have something like this on their AP Calculus and come to me and say, I can't do this without a calculator, which means they don't know how to take the roots of 1, and they don't know how to raise 1 to a power. Kind of sad, isn't it? This is the same as taking the positive root of 49, which is 7. Check. New problem. The 4th root of 625 cubed. Well, with all these 25s, I bet you anything that 625 is 5 times 5 is 25 times 5 is 125 times 5 is 625. I bet you this 4th root of 625 is 5. 5 cubed, 5 times 5 is 25 times 5 is 125. You can do it in your head. New problem. Oh, 1 again. 1 is 1, and all alone and evermore shall be so. The cube root of 64, you should get this one memorized. That's 4 to the 4th power. 4 times 4 is, well, 4 cubed is 64 times another 4 is 256. One of those computer numbers. 4th root of 16 is 2 to the 7th power. It would be 2 times 2 is 4, 8, 16, 32, 64, 128. Hope you're getting this. I'm doing a lot of these problems. There's that 4 again. And I'm probably doing more than what I need to. But I hope you get the idea. All of these can be done mentally without a calculator. Let's move on to the next one. That was Easy Powers. Let's move on to the next component. Multiply with rational exponents. Here we get a chance to use the rules of exponents in a much more sophisticated way. I have a little blackboard over here, so I wanted to clear that up. Here we have a kindergarten number 4 and a kindergarten number 2. Then we have this x to the 2/5 and x to the 1/2. The kindergarten numbers are still going to multiply like they did when they were in 3rd grade, which is 4 times 2 is 8. when you have the same base with different powers, when you multiply, you add. So I'm going to have to add 2/5 and 1/2 to find the power that belongs on that x. Well, you can't add unless you get a common denominator, so this would have to be tenths. So 1/2 would be 5/10, and this would be 4/10, so it's going to be 9/10. So this is going to be 8x to the 9/10 power. Check, we win. New problem. Oh, almost the same. This one's going to be 8 again for the kindergarten numbers, and I'm going to have to add 1/4 and 5/2. 1/4 plus 5/2. Can't add them unless we get a common denominator, which is 4, so 1/4 plus 10/4. Looks like it's 11/4 power. Hope you get the idea. Check, we win. One more. 3 times 3 is 9. X. Now we have to add the exponents here. 3/5 and 1/2. We can only add things that are alike, so it looks like the common denominator would be 10. This would be 6/10. This would be 5/10. So it looks like it's 11/10 again. I hope you get the idea. Even if you're not in calculus class, it would be good if you'd learn how to do exponents by your own mind. Now let's do powers of a power. Raise a power to a power, multiply the power, as I told you on it, plus 10/4. Looks like it's 11/4 power. Hope you get the idea. Check, we win. One more. 3 times 3 is 9. X. Now we have to add the exponents here. 3/5 and 1/2. We can only add things that are alike, so it looks like the common denominator would be 10. This would be 6/10. This would be 5/10. So it looks like it's 11/10 again. I hope you get the idea. Even if you're not in calculus class, it would be good if you'd learn how to do exponents by your own mind. Now let's do powers of a power. Raise a power to a power, multiply the powers. So we want to raise everything to the 2/3 power. The 8 is in this quantity, and it has to be raised to the 2/3 power. So it has the same thing as when we did easy powers. The first thing we're going to have to do with this 8 is take its cube root, which the cube root of 8 is 2, squared is 4. So this is going to be 4. And then to figure out what the power is on the x, raise a power to a power, multiply the power. So this would multiply to 2. Oops, not that many 2's. Come on. Hope I got them all out. No, I didn't, did I? Let's see if I got that right. It would help if I had number lock on. 2. Raise the power 15ths. Check. I'm hoping that I haven't been betrayed by that box. There we go. Raise the power to a power, multiply the powers, so the power on x would have to be 1/12. Might as well do that before we get into trouble. But 9 has to be raised to the 1/2 power. 9 is a kindergarten number, so really taking the square root of that, which is, or the positive root of that, that'd be 3x. Check, we win. And miscellaneous is, I can't even remember what I was trying to do here. Oh, here. This is a little bit tricky, but I put a disclaimer up here. Assume all variables are positive, or else I would have had to think about programming where we put the absolute value around certain variables. So when you get into pre-calculus and calculus, sometimes you're going to have to put absolute values around things that simplify, but it was going to be too hard for me to check electronically, so I put this little disclaimer: assume all variables are positive. So we want to take the second root. So out would come, let's see, we have 4x to the 4th, y to the 6th, and this is an understood square root, or second root. So 4 coming out would be 2. This is the same as 4 to the 1/2 power, so this is going to be x to the 2nd. This is the same as 6 to the 1/2 power, so this would be y to the 3rd. And this is how you enter this. You put the 2x squared y cubed. Check, we win. This time we're taking the 5th root. The 5th root of 32 is 2. This is x to the 10th to the 1/5 power, so it'd be x to the 2nd, y to the 2nd. Check, we win. So this is miscellaneous, but pay close attention to the fact that we're assuming that all the variables are positive, and explain the absolute value in the answer. I put a little disclaimer down here for those of you that need that. Oh, it looks like I did more than I thought. Maybe I wasn't as lazy as I remember. See if I know about the use of absolute values. Explain about the use of absolute value. Tells you if it's an even root, an even power, you have to put absolute values around anything with an odd power. So if you check here, I will be checking to see if you put in the absolute value. Maybe we should do one of those. See, I wrote this so long ago, 2008. I forgot how industrious I was. Let's try one of those. It has to be an even power here and an even power here before, so it's not going to be. So this is just x to the 3rd. X to the 3rd. Check. We win. New problem. This is still not even power, so it's going to be x to the 9 to the 3rd is going to be x to the 3rd. Check, we win. X to the 15th to the 1/5 power, that's going to be x to the 3rd. Check, we're kind of in a boring place here. Let's see if we can't get one that's got even. Let's see, this is even, and it has to come out as an odd. So we have here, this would be x to the 6th, so it would be x cubed. But x cubed, if x were negative, could end out being negative. And we have to guarantee that this represents only the positive roots, so we'd have to put absolute value around our x cubed. Absolute value. Check, and we got that right. So if it follows this pattern on the powers, then you have to put absolute value around the variable. Maybe your teacher explained that to you a little bit. I forgot that I put it in until I read down here. But you have to forgive me. It was, let's see, it's 2016 now. So that was 8 years ago. Have fun. Learn about easy powers. It'd be really good. Thanks. Bye.